This presentation is in response to exam 3C, question number 2, concerning self-tolerance. So, as lymphocytes develop, the receptor sequences are generated randomly. And so this approach results in quite a diverse repertoire of receptors to where nearly any antigen the immune system could encounter is ultimately recognizable. So this broad repertoire inevitably contains receptors that can recognize endogenous antigens. And so we don't want the immune system to respond to these antigens, and in order to reduce the scope of its recognition abilities, there's a series of checks and balances known as self-tolerance. So self-tolerance can be divided into two general mechanisms, central tolerance and peripheral tolerance. Ultimately depending on where they take place. So central tolerance occurs in the thymus for T cells and in bone marrow for B cells. Peripheral tolerance occurs outside of these organs, at the site of antigen recognition. So specifically, this could be in the circulatory system, in the lymph nodes, lymph organs, other tissues. Checking T cells is critical as they can further differentiate into cytotoxic lymphocytes, directly killing cells they recognize via their T cell receptor. So T cell central tolerance is controlled in the thymus during T cell maturation. After initial positive selection, a cluster of differentiation markers that bind major histocompatibility complex 1 or 2. Negative selection follows based on TCR recognition of self-antigen. So the cortical epithelial cells in the thymus present the self-antigen to CD4 and CD8 T cells. Maturing T cells which bind strongly to self-antigens are clonally deleted through apoptosis. T cells which bind self-MHC complexed antigens within this Goldilocks range, not too strong, not too weak, ultimately become regulatory T cells. Tregs will come into play in peripheral tolerance. So, despite the rigorous selection criteria, not all the self-antigen sensitive T cells can be deleted. Some self-reactive T cells escape and make it into the periphery. So peripheral T cell tolerance serves as a secondary checkpoint. Peripheral tolerance has multiple arms. You have thymic Tregs, suppressing autoreactive T cells. New studies shown that there's an additional population of Tregs generated in the periphery. Both population of Tregs have been shown to inactivate self-reacting T cells via a cell surface protein and inhibitory cytokines. Furthermore, surface receptors can shift self-reactive T cell effector cells towards anergy, or this non-reactive state. Specifically, programmed death receptor 1, PD1, and its ligands, as well as cytotoxic T lymphocyte associated protein 4, activate and result in anergic cells. So, finally, self-reactive T cells can be deleted in the periphery through apoptosis, which will be induced by the death receptor FAS and upregulation of its ligand, FASL. Now, much like T cells, maturing B cells in the bone marrow that react to self-antigens via their B cell receptor are restricted from moving into the periphery. So instead of immediate removal, self-reactive B cells can undergo receptor editing. So this receptor rearrangement process allows for recognition of alternate non-self antigens. If receptor editing is unsuccessful, self-reactive B cells are negatively selected and clonally deleted. This is done through apoptosis, and this essentially serves as B cell central tolerance. Now, also like T cells, there's an opportunity for B cells to escape the screening process. But unlike T cells, B cells require signaling from T helper cells. So T helper cells are these mature effector T cells, which have further differentiated into a subtype, and they help intracellular pathogens like bacteria and protozoa, or support immune effectors in defense from pathogens. So during an immune response against exogenous threats, T helper cells will complex with B cells via the MHC2 recognition. Lacking in the signaling via the MHC2, self-antigen recognizing B cells receive only one signal from binding of antigen and ultimately undergo anergy. This is why T cell tolerance is so critical, since helper T cells providing positive signaling to a self-reactive B cell would be bad news. Therefore, these helper T cells undergo regulatory checks during differentiation expansion also.